Today, we're pulling back the curtain on a technology that is, well, pretty much everywhere, often in ways you wouldn't even guess: machine learning. We're going to dive into how computers are actually learning to think, to predict, and even to create. So let's jump right in. So let me kick things off with a pretty wild and totally true story that just perfectly captures the power of what we're talking about. How on earth did a major retailer figure out a teenager was pregnant before her own dad did? The answer? You guessed it, is machine learning. And by the end of this, you'll know exactly how they pulled it off. All right, so here's our game plan. We'll start with the basics, what is machine learning? Then we'll explore the three main ways machines learn: with a teacher, all on their own, and through good old-fashioned trial and error. And finally, we'll see how this all comes together in the real world. First up, let's tackle that big question. What is machine learning really? Let's break it down. At its heart, machine learning isn't some single magical thing. It's more like a giant toolbox. Instead of programming a computer with super specific instructions for every little task, we design algorithms that can learn and spot patterns directly from data. It's all about learning from experience. So, the first tool in our toolbox is called supervised learning. And honestly, the best way to get it is to think of an algorithm as a student who has a very, very patient teacher helping them study. So picture this. We give our algorithm a massive data set where all the answers are already included. It's kind of like giving a student a huge stack of flashcards. You've got the question on the front and the correct answer on the back. The whole point is for the algorithm to figure out the rules that connect the questions to the answers. And this visualizes that flashcard idea perfectly. The algorithm gets fed thousands and thousands of pictures that are all neatly labeled car or motorcycle. After seeing enough of these correct examples, it starts to build its own understanding. So later, when you show it a brand new picture it's never seen before, it can make a really good guess. And this brings us right back to that mystery about Target. This is exactly what they did. They used supervised learning. They looked at the shopping histories of women who they already knew were pregnant from their baby registries. They found a pattern across about 25 different products, things like switching to unscented lotion or buying certain vitamins. So by labeling that shopping behavior as pregnant, their algorithm could then spot that same pattern in other shoppers and predict who is expecting, sometimes with shocking accuracy. Okay, but what happens when you don't have all the answers labeled? What if there's no teacher, no flashcards? Well, that brings us to our next category: unsupervised learning. Now, in this case, we're basically throwing a whole jumble of data at the algorithm and just asking it to, find something interesting. Find the hidden structures, find the natural groupings, all by itself. It's like someone dumping a giant box of Legos on the floor in front of you, and you have to figure out how to sort them without anyone ever telling you what color or shape is. And you can see what I mean right here. The algorithm gets a big mix of apples and cherries and oranges. It has no idea what they're called, but it's smart enough to figure out, hey, all these things are round and orange, and all these other things are small and red. It discovers these clusters all on its own. And this is where it can get kind of mind-blowing. When Walmart analyzed shopping data before a big hurricane, their unsupervised model found all the obvious stuff, right? People buy more water, more batteries, but then it found this completely random, unexpected connection: strawberry Pop-Tarts. Why? The algorithm stumbled upon a really subtle piece of human psychology. It turns out when we're stressed, we crave simple, non-perishable comfort food. So armed with this totally unexpected insight, Walmart actually stocked up on Pop-Tarts right next to the hurricane supplies, and they flew off the shelves. That's the power of finding a pattern no human would have even thought to look for. All right, let's get to our third and final type of learning. This one isn't about labeled data or finding hidden groups. This one is all about learning from action and feedback. Think of it like learning how to play a video game. So with reinforcement learning, you have what's called an agent. That's our algorithm. And it's placed in an environment. It tries different actions, and for every move it makes, it gets either a reward or a penalty. Its one and only goal is to figure out the best sequence of moves to get the highest possible score in the end. A perfect example of this in action is when the AI company DeepMind taught an agent to play the classic Atari game Breakout. It didn't get any instructions on how to play. All it knew was that a higher score was good and a missed ball was bad. So through millions and millions of attempts, it just taught itself the perfect strategy. And how well did it learn? Was it any good? It became an absolute master. In Breakout and dozens of other classic games, the AI achieved scores that were more than 75% of the level of a professional human gamer.
all just by playing and trying to rack up points. So, we've got our 3 big learning styles down. Now let's bring it all back to the real world and see how these tools are used in ways you probably run into every single day. This table gives you just a little peek inside that toolbox. You've got algorithms like random forests, which are fantastic for complex stuff like detecting credit card fraud. Then there's logistic regression for simpler yes or no questions like, is this customer going to cancel their subscription? On the unsupervised side, K-means clustering is what helps businesses group customers into different segments for marketing. And collaborative filtering, that's the magic behind the recommendation engine on Netflix or Amazon, suggesting what you might like based on what people similar to you have enjoyed. So, if you remember one thing from all this, let it be this. There is no single machine learning. It's a big, diverse toolbox. The real skill is knowing which tool, supervised, unsupervised, or reinforcement, is the right one for the problem you're trying to solve. And that idea that it's all just a toolbox, it leads to a much bigger, more important question, doesn't it? As these tools get more and more powerful, the conversation changes. It's not just about how machines learn anymore, but about what data we feed them and what goals we ask them to achieve. So you have to wonder, what is the most important thing we should teach them? That's something to think about.